Okay, in this video, we are going to talk through cost and marginal cost and average cost and marginal average cost. I'm going to split this up into two videos because it is a lot of information. So first we have, so we're going to do some business applications. That's the whole point. So some notation first for cost, revenue, and profit. We use a C of X, an R of X, and a P of X. When we're talking about marginal cost, marginal revenue, or marginal profit, it's the derivative. So this would be C prime of X, R prime of X, and P prime of X. For average cost, revenue, and profit, this is kind of bizarre, but it is the cost of X items divided by the number of items. So C of X divided by X, R of X divided by X, and P of X divided by X for cost, revenue, and profit. We're often going to write those as C bar. That would be the average cost. The average revenue is R bar, and the average profit as P bar of X. Then for marginal average cost, take the derivative of those things. So it would be d by dx of C bar of X, and d by dx of R bar of X, d by dx of P bar of X. Okay. So marginal cost is approximately the cost of producing one more item. So the derivative of cost gives us a way to estimate the cost of the next item. Similarly for revenue or for profit. So C prime of X is approximately equal to the cost of producing the next one. So the cost of producing the next one minus the cost of producing that one. This would give you the cost of producing one more item. So the derivative gives us a way to approximate that. And it's just a nicer calculation because you only have to do it once, and then you can plug in whatever value for X you want to, instead of having to do two calculations every time you want to figure out the cost of producing one more item. Okay, excuse me. Excuse me. Okay, so we are then looking at, let's look at this example. We have the cost of producing something is 225 plus 2x squared. C of 10, when you plug it in, the cost of producing 10 items is 225 plus 2 times 10 squared. So 225 plus 200, which is 425. And then when you plug in 11, you have this. So 225, 121 times 2 is 142. 242, not bad. So 225 plus 242 is 467. So the actual, excuse me, the actual cost of producing the 11th item from the 10th to the 11th, producing that one more, is going to be C of 11 minus C of 10, which would be 467 minus 425, which is $42. So to produce the 11th item, they will have to spend $42 more. Now, what we just wrote down says that C prime of 10 should approximate that. So let's check that. What is C prime of X? The derivative, here's our function again, the derivative of this would be 0 plus 2 times exponent down front, decrease it by 1. So that is 4x. So C prime of 10 is going to be 4 times 10, which is 40. So this is a pretty good approximation of the actual cost, right, of producing the next item. Okay. So the marginal cost or revenue or profit is an approximation of producing, of the cost, revenue, or profit of producing the very next item. Okay, so we're going to do a couple application problems with that. So a supplier of a souvenir t-shirt, it charges street vendors for each order based on a setup fee of $50 and then item charge of $1.15 per shirt. What is the cost for the vendor? So the cost of X shirt would be the like regular fee of $50 plus $1.15 per shirt. So that is your cost function. Okay, now for something a little more challenging. We have the total cost in dollars of producing X electric guitars is 1,000 plus 100X minus 0.25X squared. And so what we're going to do is find the exact cost of producing the 51st guitar. So the exact cost here means don't do a derivative. You want to do C of 51 minus C of 50. Okay, so I have those numbers written down. C of 51, I have 544,975, and C of 50, I have 5,375. So the actual exact cost of producing the 51st guitar is $74.75. Okay, if we want to use the marginal cost, the derivative, this when you see marginal, you think derivative. So I want to do C prime of X. The derivative of 1,000 is 0. The derivative of 100X would just be 100 because that would become X to the 0 power, which is just 1. And then we have the 0.25 exponent down front, decrease it by 1, it goes from a 2 to a 1. So we're looking at 100 minus 0.5X. So that is C prime of X. We want to know what is C prime of 50, because that will approximate the producing the very next guitar, which would be the 51st guitar. So 100 minus 0.5 times 50, and this is equal to $75, which is pretty darn close to $74.75. So again, to find the exact cost, you're not going to do a derivative. You're going to do the cost of the 51st minus the cost of the 50th. That will tell you how much more they spent to make the 51st guitar. If you want to approximate that, you're going to use the derivative and the marginal cost. So you're going to do C prime of 50 because that will tell you how much it would, it tells you the slope, right? So it tells you how much to it's changing to get to the next one. Okay. The total cost in dollars of printing X dictionaries is C of X equals 20,000 plus 10X. Find the average cost per unit if 1,000 dictionaries are produced. Okay, average cost, here's the thing we see. Average cost is C bar of X, which is going to be C of X over X. So that would be 20,000 plus 10X all over X. So that would be 20,000 X to the negative 1. Actually, don't do that yet. 20,000 over X plus 10. And if I wanted to, because I'm going to have to take a derivative in a second, and I know that, I'm going to go ahead and do this as 20,000 X to the negative 1. So this is an X to the first power plus 10. Okay. I am supposed to be finding the average cost per 1,000. So I'm going to do C bar of 1,000 now, which I just did. This is 20,000 X to the negative 1. So 20,000 times 1,000 to the negative 1 plus 10. Let's calculate it out. Okay, that was 1,000 to the negative 1. That was just 20,000 divided by 1,000. Plus 10 is 30. This is 30. Okay. So this is the average cost per unit if 1,000 dictionaries are produced. That's your answer there. I need marginal average cost. So we see the word marginal again. This tells us take a derivative. So we're going to do C bar prime. And this is going to have, I'm going to take the derivative of the cost function, the average cost function, which was 20,000 x to the -1 plus 10. Taking a derivative of that first part, I'm going to put the exponent down front, decrease it by 1, and then the derivative of 10 is 0. So this is the marginal average cost. And I want to know this at 1,000. So I'm going to do C bar prime of 1,000. So I plug in -20,000 times 1,000 to the -2. -2. Let's square that on the bottom, and that is -0.02. So I'm going to try to write this in words. The rate of change of cost per unit when producing 1,000 units is -0.2. Rate of change of cost per unit at 1,000 units is -0.02. So producing one more would decrease the cost per unit by 2 cents. Which if you're making a lot is a lot, right? The cost per unit by 2 cents. Decrease the cost per unit by 2 cents. Okay, so use the results from parts A and B to estimate the average cost per dictionary if 1,001 dictionaries are produced. So this is the cost per dictionary. So right now at 1,000 units, the cost per dictionary is $30. If we made one more, then the average cost will decrease by 2 cents per dictionary. So it would be $29.98 per dictionary. So you're looking at $30. It's decreasing that by 0.2. So you do plus -0.02. So $29.98 per dictionary. So the marginal average cost there, it's the rate of change of the cost per unit, because that's what the average cost is. And then the marginal part is the rate of change. So the marginal average cost is the rate of change of the cost per unit at 1,000 units. Okay, I'm going to pause here and pick up the marginal revenue and marginal revenue in a different video.